Download this code from codegib.com, link in the description below. I cannot provide a tutorial specifically addressing GZipStream read async blocks with a zero-length buffer 52009 GitHub because that phrasing points to a specific, potentially erroneous, situation found in a particular GitHub issue, which I don't have access to. A zero-length buffer in read async is generally incorrect and will not read any data. However, I can provide a comprehensive tutorial on using GZipStream with read async effectively, including best practices and addressing common pitfalls. This tutorial will cover scenarios that might lead to problems similar to the implied GitHub issue. Understanding GZipStream and read async. GZipStream is a class in .NET that provides compression and decompression capabilities using the gzip algorithm. Read async is an asynchronous method that reads data from a stream. Using them together allows for efficient, non-blocking decompression of gzipped data. Key concepts asterisk asynchronous operations read async performs its operation asynchronously, meaning it returns immediately and doesn't block the calling thread while waiting for data. This is crucial for responsiveness in applications. Buffers read async uses a buffer to store the data read from the stream. The buffer size significantly impacts performance. Too small, and you'll have many read operations; too large, and you waste memory. Cancellation asynchronous operations can be cancelled using a cancellation token. Exception handling always wrap read async calls in try-catch blocks to handle potential exceptions, like I/O exception. Code example: efficient gzip decompression with read async. This example demonstrates efficient decompression of a gzipped file using read async and a properly sized buffer. Explanation (1) Error handling the code includes try-catch blocks to handle potential I/O exception and other exceptions. 2. Buffer size a buffer size of 4096 bytes is used. This is a reasonable default, but you might need to adjust it based on your needs and the size of your gzipped files. Larger buffers are generally more efficient for larger files, reducing the overhead of many small reads. 3. Cancellation token the cancellation token source allows for cancellation of the decompression process. This is good practice for responsive applications. 4. Read async loop the while loop continues reading data from the GZipStream until read async returns 0, end of stream. Crucially, it reads into the buffer and then writes that buffer's contents, up to bytes read, to the output stream. This prevents writing unnecessary 0 bytes if the buffer is larger than the remaining data. 5. Write async this mirrors the asynchronous read with an asynchronous write, optimizing the overall process. Addressing potential issues, relating to the hypothetical GitHub problem. Zero-length buffer never use a zero-length buffer with read async. This will cause the method to return immediately without reading any data. The buffer must have a size greater than 0. Incorrect buffer handling ensure that you're correctly specifying the offset and count parameters in the read async call. The offset should generally be 0, and the count should be less than or equal to the buffer's length. Stream disposal always ensure that streams are properly disposed of using statements to release resources. Remember to replace input.gz and output.txt with the actual paths to your input and output files. This improved example avoids the likely pitfalls that led to the assumed GitHub issue and provides a robust and efficient approach to asynchronous gzip decompression in .NET. If you encounter specific errors, provide more context, including the error message and relevant code snippets, for more targeted assistance.